prepared questions. And so we'll go through those questions, and then we do hope to leave some time at the end for those of you in the audience to ask questions as well.
This may be a bomb, it may be good, who knows?
So maybe we'll ask that everyone please mute yourselves before we get started, just so that we can all hear Victor and his responses. My first question, Victor, is around your journey. And, you know, one memory I have, I'm not sure if I shared with you before, one of the sort of most vivid memories I have of my early days in working with you as a graduate student was when I lived in JP and you lived in Roslindale at the time, and I used to bike into HSPH along the bike path in JP, along the JP pond. And one day I was biking in, and you came up behind me, and as you still are now, you're in better shape than I was back then. So I was sort of chugging up the hill, and you were, you know, going quite fast up the hill, and you know, you're chit-chatting with me. It was when I want to say it was within a few months of starting to work with you on my dissertation, and you asked me what I wanted to do when I graduated. And at the time, that was sort of like asking maybe a 17-year-old now where they want to go to college, right? Like I was a little mortified by the question. And I stumbled a bit and said, you know, I wanted eventually to work with the World Health Organization. And you said in your usual sort of wise way, you said, well, you know, really, you should do what you want to do now, and you'll get to where you want to be. And I've thought about that piece of advice that you've given me, for the past couple of decades, and have shared it even with my daughters on numerous occasions. But I'm curious now to ask you a little bit about your journey, and sort of whether that, if your own advice kind of held for you. And, you know, just a little way of background for everybody here. Prior to starting your PhD in biostatistics at the School of Public Health, you were a physics major at Brown. You received a master's in bioengineering at Harvard, and then another master's in epidemiology at Harvard. You taught mathematics and physics at the Commonwealth School in Boston, and believe you traveled all around the world as well. So I'm wondering if you can describe a bit of your journey and why you decided to pursue a degree in biostatistics.
Well, thanks, Andrea. First, I want to say I'm very glad the advice that I gave you worked out for you. I'm not sure how well it worked out for me at different stages, but it's still what I believe, actually. So it's nice to know that my beliefs, at least sometimes, can correspond to reality. My journey, as you pointed out, where you give a little bit of my CV for my 20s, was quite circuitous. And I had always thought I would stay with physics until I actually started doing what physicists do. It was one of those beliefs that didn't really stand up to reality. So I was a little bit undecided, did bioengineering, did not like animal experiments, did epidemiology, really wanted more depth in the quantitative methods than was being taught at the time. Now it would be quite different, of course. And taught and thought that was great, worked for National Center for Health Statistics, and never quite found my niche until I was working at Channing Laboratory as research associate, and the HIV epidemic started, first entitled GRID, and actually on the bulletin board at Channing Lab, they had the first New England Journal article about HIV in 7 people, 6 gay men and 1 woman. And so I was very concerned about this. but was still torn between doing a biostat doctorate and going to business school, actually. And so I went out to Berkeley Business School, where some friends had gone, and stayed with them. And we talked a lot about grid. And when I got back, I found out that one of them was in the hospital with symptoms that later turned into AIDS, which wasn't treatable at the time. So that really swung me towards the direction of public health. But there was one other major event, which is I got to go to one lecture by Jim Ware, and I thought it was so wonderful. I said, well, okay, this is decided. But I started the doctoral program in 1982 with the intention of doing research on this new pathogen, which we now call HIV. And really wasn't even on people's radar much at the School of Public Health. But of course, it grew into an enormous public health problem throughout the globe, and I've kind of stuck with it ever since, with a few diversions to hepatitis and now COVID.
Great. Well, that's a really interesting process, and it does sound as though you were sort of following your passions at every level, and also really interesting to hear that you actually knew in starting your PhD that what precisely you wanted to study, because I think that's a bit unusual, really interesting. So then, of course, fast forward 35 years later, and you have really become a preeminent scholar in HIV and AIDS research. As early as 1989, you received the prestigious first award from the NIH and the National Institute of Allergy and Infectious Disease on statistical modeling of progression of HIV infections. And I would venture to say maybe that was probably one of the first, if not the first, methods grant in HIV that the NIH would have awarded. And you were continually funded for, I believe, 17 years on an NIH R01 that turned into a merit award from the NIH on your work on methods for long-term follow-up of HIV-infected patients. And of course, you've collaborated with dozens, maybe hundreds of other distinguished scholars, biostatisticians, and clinical investigators, and have conducted research across the globe. So I'm wondering if you could speak to how you chose the research topics that you ended up working on, and who to work with, and what some of the factors or people were that most influenced your choices throughout your career.
And I want to thank you for the kind words, and make one comment. Actually, the first methods grant to the Biostat department was to Steve Lagakos in 1986. I helped write that grant. In fact, I was doing Fulbright in France, came back to help write the grant, went back to France so that it could support me as a postdoc when I came back. So that all worked out. And then I continued from there. With regard to, since the start of the AIDS epidemic, I would say follow your passions has been my guiding principle. And the first fairly close colleague that I had, whom I'm still working with, is Ken Mayer, who was at that time a fellow in infectious diseases at the Brigham, and now a professor at medical school. And my first collaboration with him grew out of a fairly intense argument that we had about what was the actual risk to people who were engaging in risky behavior, and what was the appropriate recommendation. Because I thought the recommendations were not just poorly worded or somewhat misleading. I thought they were very much counterproductive. And the only way to resolve a debate like that, I have found out, is to write a paper, because that forces you to come to grips with where your similarities and differences are and how you can present. And that, and another great friend joined that effort, Bill Bennett. That was my first published paper as first author. And so from that paper was an investigation of the recommendations. First of all, the beliefs about the epidemiology and natural history of HIV and the recommendations. What was being touted as a good advice to people at risk was to have no more than 2 new partners per month. And that was based on the belief that only people with very high levels of exposure would get infected, and only 5% of the infected would develop disease. All of those were results of a failure to take into account the sampling that was leading to those beliefs that arose from taking simple averages. So that really turned out much more than I expected to be an agenda for research. And one of the areas that I was most concerned about was HIV in hemophiliacs, because of the terrible risk I thought that they might be experiencing. So as a student, I went over and talked to a hematologist at the medical school, and she was a wonderful woman, and she gave me a lot of detailed information, but I had trouble communicating what I thought was the level of risk. So I ended up, after finishing my degree, to do a Fulbright in France, where kind colleagues there put me in touch with a hematologist who gave me all of the detailed records he had on his patient population and others in Paris, from which I could study the effect of repeated exposure on risk of transmission, and also on the risk of progression from infection to AIDS. But that required solving a methods problem, which is that the time of infection is never known, almost never known. Exactly what you know is the interval in which it occurs. And so the endpoint is interval censored for the time to infection, and the initiating point is interval censored for the time to disease. So that led to a methods paper with Steve Lagakos being funded by the grant that I had helped write. And then my first experience in helping to guide a dissertation project, when Steve suggested that I work with Mimi Kim on developing a method that allows for doing regression onto continuous variables from these interval censored event times. So that really, I don't know, did I find the problem? Did the problem find me? It always seems much more like the problems find me. I never go looking for problems, but they appear. And you know, that was the first, my first focus was really on methods for studying epidemiology and natural history.
Mm-hmm.
Next focus was when the department became the statistical coordinating center for the AIDS clinical trials group. And we were thrust into the treatment agenda. And I know Kristen is still working at the Statistics and Data Analysis Center for the AIDS Clinical Trials Group, now for COVID research as well, under the amazing direction of Michael Hughes. And so that thrust me into the treatment agenda. When I was working with you, Andrea, we delved deeply into the antiviral resistance agenda. And that, I think, was an extremely important development when the technology arose that allowed for sequencing the genome to find out what drugs it was sensitive to. So that was, we had finally developed effective treatments, and there was terror that they were going to be lost to resistance. And then that problem was pretty well solved. So I jumped to the prevention agenda, which seemed to me to be the most, now that treatment was really available and bringing down mortality, although of course never as widely accessible as we hoped, and always with less access to the most vulnerable communities. So there was remain now very important problems. But I thought that the biggest contribution I could make at that point would be in the prevention agenda, particularly in vulnerable communities. So that's kind of my life history in a nutshell in terms of research focus. And, throughout the course of this, of course, I had amazing colleagues at the School of Public Health, amazing students and postdoctoral fellows, of which you're in all three categories, clinical investigators who I got to know, as you mentioned, from around the US and around the world, who helped and supported me every step of the way and made possible right from the start for me to follow my interests. And I'll always be grateful to Catherine Hill, who's the person who invited me to come to Paris and caused me to apply for the fellowship, for linking me up to this wonderful hematologist who created the basis for my first papers. Long answer to a short question.
Well, it's a great answer. And it sounds like you're saying that you both followed your passions, but also really were fortunate to have a lot of opportunities put in front of you to be able to do that. And many of the things you've mentioned are obviously things that those of us working in long COVID are thinking about now, and some of the similar challenges, and particularly in reaching vulnerable populations. And understanding risk, as we're talking, it's just in the beginning. It seems like as you're talking about this progression of research, of starting with the sort of natural history, moving to trials, resistance, and ultimately prevention. That I imagine in our current state, we're similarly going through these phases, and there's been obviously a lot of conversation around risk and understanding risk. But I have to say, the one thing I'm definitely taking away from this was your first comment that we should choose to work with people that we disagree with the most, and that's that's going to give us the most. We're going to learn the most, perhaps, from that process and writing papers with those individuals. So
I would amend that very slightly to say the people you disagree with the most, and also like the most. If you disagree with them and you don't like working with them, it might not work as well. But frankly, I've always been very fortunate to work with people that I just think the world of.
Yeah, I think you tend to like most people too, Victor, is my sense. So it's moving on to this a little bit more about the context of your work and sort of the broader society. So as you were pioneering the research that you were doing in HIV in the 1980s, the country was really overwrought with political and social turmoil. By 1987, we had over 40,000 people who had died of AIDS in the United States, and as many as 10 million who were infected worldwide. The organization ACT UP was formed during this time, and many credit the very fast and expedited availability of experimental drugs against HIV, and as well as the fast tracking of research funding through the NIH. So this is something that's still ongoing, right? That HIV grants are reviewed much faster. They credit these to the activism of ACT UP members, as well as their partnerships with scientists. So the members of ACT UP built partnerships with scientists, and that really paved the way for some of these really profound changes in how the treatment was being provided and funding was being passed. And at the same time, more locally, the Massachusetts legislature was considering a gay rights bill, which eventually passed in November of 1989. I was wondering if you could talk a bit about how the socio-political climate in the 1980s and 90s as it related to the HIV pandemic and the public health response impacted your professional choices, and how you engaged and tried to communicate across the broader scientific and activist communities or governmental agencies.
Well, yes, and thank you for asking that question, Andrea, and giving me the opportunity to sort of relive those very tragic but often very exciting times. And I have to say there was a tremendous tradition within the biostat department at Harvard to do community-based research and engage with communities. And that was really a core principle of Marvin Zellen's and Steve Lagakos. And I think many people, or some people, may be aware of the famous Woburn study of contaminated water that got turned into a movie that left out the statisticians, but at least Marvin and Steve got invited to a premiere. So it was clear to me from the start that we needed to have much better communication and relationships with all aspects of the affected communities. Now, in some cases, that was very natural and flowed along smoothly. In other cases, it was more contentious. And I think I'm sorry.
I think, Bob, that's your iPhone. I don't know if it's possible.
Oh, Bob, you need to mute.
Oh, I'm sorry. Sorry about that.
No problem.
And so that is my friend, partner, Bob, who was kind enough to join this evening. And it's actually, when we're starting to talk about some of the more personal aspects of the involvement of the department with the different affected communities, Bob piped up at exactly the right time. So there were contentious issues, and I think cases in which the different types of activists were very accurate, and there were settings in which perhaps less so. But the first thing to say is that there was enormous diversity within the activist. It wasn't a community, it was activist communities of affected people. And the strongest contributions and perhaps the best remembered people are people like Mark Harrington and Greg Gonzalez, who both received awards. Now I'm blanking on the name of the MacArthur Fellowships. And Greg is now kind of a esteemed professor of public health at Yale, and they were very much part of the activist communities. And but I remember it as a very broad collection of people. And when we first started going to the AIDS clinical trials group meetings, activists who attempted to participate were being escorted out of the meetings. So I asked Marvin and Steve, can we have our own community representation at the School of Public Health? And they said yes. So with Ken, again, who pops up, repeatedly throughout my life, gave me a list of all the people that I should consider inviting. Nearly all of them came. Steve came to the first event. I think Marcello did also. And you know what it taught me? Close reading of protocols. Because even though I was working with the AIDS clinical trials group and working with protocols, my idea, well, let's get to the action, the stat section, you know, the aims and the stat section. So they, you know, taught me carefully reading the whole thing. There was a very wide range of perspectives, but I think we worked really productively together. And at a time when there was some people within the AIDS research community that weren't completely persuaded of this approach. I was. And the amazing thing was, given the diversity of people who showed up and the fact that there had been contentious meetings, and I think very inappropriate things said about some very fine people, and which we're seeing again in COVID. Nonetheless, I thought that this was the important thing to do. But one of the things that really amazed me is Marvin not only approved it, he provided some funding to help facilitate anything I needed to get it going. And I was so abashed because I was expecting pushback. Can I say I was welcome it? Not really, but you know, I was kind of ready for that and to be embraced that warmly. I don't think I ever thanked him properly, so I'll have to thank him now. So, you know, the department was great, but it was right after the first sort of expulsions when the most estimable Tony Fauci invited the activists to, not the activists, that's too broad a category, a set of influential activists to his house for a weekend, and came back and said, okay, not only are they invited in, they need to be part of every scientific community, every protocol team. So he really flipped a switch. And the whole world of research, I think, benefited from, you know, very much from the efforts of the treatment activists of all stripes, but also from Dr. Fauci. I have one slightly funny story to mention. I don't know how we're doing with time, but in any event, one of the things that happened right when we were having our own community group was that there was big demonstration in favor of a more rapid approval of a drug called DDI. Not really the best drug, but nonetheless, there were, you know, reasons to approve it. And so they decided to hold the demonstration in front of the School of Public Health. Now, they would never have even probably known anything about what we were doing and with regard to the AIDS clinical trials group, but they chose that spot. So I went to talk to Steve and I said, oh, you know, there's demonstration outside. And he gave me that famous Lagaco smile and said, oh, go down and join your friends. So it was, you know, it was really wonderful to have that freedom that I had.
Yeah, it sounds as though, you know, what I'm hearing a lot of is the recurring theme of a lot of support of folks around you, and this freedom that you're describing that allowed you to really pioneer in this area. And it's true. We're, those of us who are moving into some of these research areas now, that we see that, community engagement, patient advocates, and are really critical to these projects and do provide extremely important perspective to them. So thank you for helping to pave the way for that, because it's clearly really vital to the success of these projects. So moving a little bit to public health messaging in general around biostatistics, and thinking particularly around the more recent COVID pandemic. We've seen that the response of biomedical and public health researchers to COVID has had some enormous successes, including the development of vaccines using these new technologies in extremely rapid timeframes, as well as failures experienced in the delivery of these vaccines to critical populations. And similarly, we've seen the benefits of masking, especially in vulnerable groups, which has been documented and communicated, yet there is still strong opposition to masking in some groups. I'm wondering what you think we can do as statisticians to contribute to these issues, for example, through more effective messaging. We'll talk about our role a bit now.
Yeah, I think that's such an important question, Andrea, thank you. And I think, it's not only important now in public health, but even more broadly in our political structure as a whole, because we've seen the enormous impact of COVID on, and the stress it's created on political structures and on political discourse. And so the importance of getting messaging right has never been greater. I always think, you have two options when you're trying to create a policy. Either, I wouldn't say only two, but they're a mix of two different forces. One is development of evidence and trying to persuade not only political leadership, but community, that the evidence is accurate and the policies that are developed are appropriate. And the other side is just ideology, which to me is just like the first step of Bayes, which is to come up with a prior and never do the second step, which is to come up with a posterior after you've evaluated the evidence. So, I think that the messaging is vital to all of the structures that impact public health. And Bob, again, who was for years an anesthesiologist and pain management specialist at VA hospital, said, it's one thing to come up with statistical estimates and their uncertainty of things like vaccination effects on a risk of severe disease, and uncertainty in those measures, and then try to track that efficacy over time as variants emerge, for example. And you can come up with statements about that, but the question is, how do you best communicate? And what's great about having close interaction with clinicians, I think, it's nice if you speak to them every day, but even, if but that's going to limit your sources of information. So I think in general, we need to be working very closely with clinical investigators who see patients to get a sense of what was understood, which is as important as what the message was. And in that regard, I think there's a trade-off between clarity of the message and the full communication of uncertainty, particularly when you've got not only uncertainty at any point in time, but uncertainty that keeps changing over time, as with the vaccines. And I don't think that's resolvable, certainly not something I'm going to try to resolve, but I think it's a way to frame the discussion, because the fear is that if you keep the message very simple and encouraging, it may turn out not to be fully true. I go back to the 5% of infected will get disease with AIDS, and you can lose credibility. On the other hand, if the message is too complicated, will people just tune it out? But, but I, excuse me. To me, the most important part is, how do you communicate uncertainty? And this is where I think the Bayesian approach really helps. I think it's very hard to communicate what a p-value is. I think, frankly, a lot of clinical investigators don't really know and confuse it with a posterior probability. So maybe we'd be better off talking about posterior probabilities, since to the extent people know what p-values are, they think often think they're posterior probabilities anyway. And at least people have some sense of that, like from the daily weather report. But more generally, I think that we need to start thinking more about how to communicate uncertainty from the very beginnings of education. And one example I'll have is when we first learned about Mendelian genetics in school. I think it was grammar school, or maybe beginning of junior high school. And it was wonderful. Like a quarter of the peas will turn to be green and 3/4 will be white, because the gene for the white beans is dominant and the green is recessive or something. But, it'd be the perfect time to introduce the idea of the probability is 1 in 4. Most kids have played dice or some other gambling game. And even though that probably shouldn't be encouraged, but nonetheless, they have a sense of it. I think we need to start there. We need to think about people at all levels of education, at all life stages, because this is so central. And, a prime example to me of where you can lose credibility was related to statements from some powerful people in public health that if you got a vaccine against COVID, you could go into restaurants or bars without masks. So that was a very clear message, and it was a powerful incentive. And as it happens, both I was spending the summer on the Cape next to Provincetown. That actually, and it was right at that time that the super spreader event in Provincetown, arising from a big 4th of July weekend, big and very rainy, where everybody was crowding into bars, and there was a super spreader event. And it turned out that as everyone later knew, but the super spreading event was particularly well documented in Provincetown because they were particularly aware of the need to do contact tracing from HIV and other things. So when that advice first came out, I knew, because I had been involved in the vaccine agenda in a lot of different ways, I won't discuss, but I knew that statement that you could go into bars safely was way beyond the facts. Just like you could have 2 new partners a month safely was way beyond the facts. And this kind of messaging problem, I think, undermines credibility. If you say, we're really sure that the vaccine against the current variant will reduce severe disease, we really know that, and we hope, that it's going to have some benefit on reducing transmission. So maybe at some point you'd even be able to, a message that does communicate what's an aspiration, what's a reality, communicates uncertainty, maybe more quantitatively to some people and in other ways, but it's not going to solve the problem, but it's all I got.
That's so interesting, Victor. And it's there's a lot to unpack in what you've just described. I think that, obviously the public health messaging around COVID was also complicated by trying to convince people to uptake the vaccine. And so, the ways in which sort of people's the sort of decisions to represent the data and the uncertainty can sometimes obviously be motivated by wanting, other factors. It's also interesting what you talked about with people's level of comfort with uncertainty, and that this is something that we can think about introducing earlier on in education to increase people's comfort level with it, so that we can be better at it ourselves, knowing how important it is. I've heard people say that, perhaps the reason data science has taken real hold, and sometimes biostatisticians feel a little bit kind of left at the wayside, is because data scientists who are, especially the computer scientists within them, don't talk about uncertainty, that there's much less about uncertainty in data science. Well, statisticians and biostatisticians are really emphasizing the uncertainty, and that, so that's in some part, maybe some explanation for why data science has kind of taken off a bit, because they've avoided that. But I agree with you completely. It's a really important point that that the credibility can be lost if the messaging is too simple, that no one will believe the messaging ultimately. And obviously there's so much distrust in science that we're seeing now in this country. So really thinking about the importance of that kind of layered messaging that doesn't integrate the uncertainty that we have is going to be really important if we want to address some of that mistrust. So thank you for those comments. So moving on, I want to just try to squeeze in a couple more questions before, and then leave some time for others here to ask questions. And if folks want to put any questions in the chat now, feel free to do that so we can be sure to get to them. So I was hoping you could talk a little bit about your leadership experience. So in addition to your really remarkable research career, you've held numerous leadership positions. You talked about SDAC for the ACTG, the adult ACTG. You were director and PI of SDAC from 1996 to 2003. And then, of course, you were the chair of the Department of Biostatistics at the Harvard Chan School of Public Health from 2009 to 2015. I'm wondering about what led you to take on these leadership positions, whether it was the same sort of, it took you, or did you choose them? And what were some of the greatest challenges, or what you learned from these experiences?
Well, thanks, Andrea. And I have to say, I never thought of myself as being cut out for leadership. I didn't seek it. But one, I think, driver for me was when I was doing the research on hemophiliacs, because my hope had been to raise questions, develop evidence that might lead to changes in practice that could have saved more lives. And that, in fact, was possible. I won't go into detail. I did develop a database. I found out I could write a methods paper on my ideas. I could direct a research. That was great for me. But I failed in my primary goal, which was to save lives. So I realized that what I was trying to do was not going to work, because without your hands on those ropes, you are not going to have the kind of impact you need. So when an opportunity arose to take leadership roles within the Stat Center for the AIDS Clinical Trials Group, I jumped at the chance and ultimately to be director. And what that enabled me to do was to play a role in the development of the studies themselves, to address range of concerns and to try to make the best progress we could, but also to have a major role in the messaging. And not only the abstracts for the conferences and the papers, which are of course the most important academically, but also in the press releases, because statisticians and I personally involved in really all of the press releases. What did the study actually show? And also to play a role in guidelines that were going to affect people's lives. There was no way that I could turn down that chance. And when it came to becoming chair of the department, after Louise Ryan said she was going back to Australia, I went into Steve Lagakos's office, my first instinct, and I said, Steve, I got a great idea who should be the next chair. And I told him. And he said, no, you should be the best chair because you will help maintain our values. And as a designer once said, in response to a recommendation from the Vogue editor, Diana Vreeland, it was like a commandment from God. So I didn't really think of myself as having a chance, but I wanted to do it because there were things that I really wanted to achieve there as well, having to do with curriculum and also with recruitment. And one of the things I'm most proud of was the recruitment of a network scientist who has moved more and more deeply into statistics, who's J.P. O'Neill. So there were great opportunities in both jobs. Of course, there are, as you know, Andrea, there are always challenges in finding ways for people to reach consensus, finding ways to make everyone, including all of the students and faculty, feel heard, and dealing with having to disappoint some people. All of that was fine. The toughest thing I've ever had to deal with was when I find that some things have not been properly represented, and that decisions made on representations now have to be reevaluated. I try to put it in the blandest possible language, but it's a reality of, I have found in my experience, when you're dealing with huge organizations, and the AIDS Clinical Trials Group, and I know Kristen has been involved several years and experiencing this now, you are dealing with all big pharma, NIH, CDC, FDA, very powerful people in biomedical research. And the vulnerabilities were endless. I remember there was a big concern that arose with pharmacology data management, which actually was not even being done under the leadership of SDAC, but by a separate company. But I still got dragged in and remember a famously tense trip to Foster City. I won't say what the company was, and in this case, that was, the problem was of representation, but it wasn't intentional. It was a mistake. But in any event, did it have its challenges? Yes. Would I do it again in a heartbeat?
So that's good to hear. Final question. What's next for you? And I'm also, maybe you can also touch and just, we really want to give a couple minutes for other questions, but sort of what you also think are some of the challenges for the field coming in the coming decades as well.
Yeah, I think, and I think probably we're all aware of the challenges. One of the things I'm most involved in now is HIV cure agenda, especially with a group at UCSD. That research is very deeply based in molecular biology, genomics, and viral and cell dynamics. So it's this world of huge databases, like single cell RNA-seq. It's not even small n, large p. It's minuscule n and gargantuan p. And tremendous fun, tremendous opportunity. And I think, gearing up for pandemics, figuring out how we can do better. Clearly, we need much more rapid response to pandemics. And there are some examples that really bother me about the way the public health system operates, but I have to say I really applaud the CDC and our Harvard's own Rochelle Walensky for now having a core mission of developing more rapid response. But how do we integrate across the huge databases that have so much information that can directly inform some of the biggest challenges? And one area I'm working now very closely with Ravi Goyal is on how do we combine different sources, and with Ree Rom, who's also on this call, is how do we combine across different sources of information so that we can make more reliable statements about the true impact of vaccine on transmission, and keep this goal as aspirational, not something that's already realized. So I'll stop there.
Thank you so much, Victor. Really, you continue to inspire me, and I really enjoyed your responses to these questions. And I know you've touched many of the people in this room, in the Zoom room, and will continue to do so in the coming years. So do you want to just open it up if anyone had any questions for our guest?
Hi,
Hey.
hi, Andrea. Can I ask? It's more of a. I always enjoy hearing your talk, Victor. Very inspiring, and one aspect I think may benefit for a lot of people on the call, as including myself, is you've worked with so many. You mentored so many people, students, fellows, and junior faculties. Can you tell a little bit on that? The how we can be like that, be more effective in mentoring, and your experience working with junior colleagues. Can you talk a little bit on that?
Well, I'm not sure I have any advice to give in general, and particularly not to you, Ree, because I think you were one of the most extraordinary mentors I've ever seen, having had the great opportunity to be on some of the dissertation committees of your students. But in general, I think, and maybe fairly obvious, again, the most important thing is to find out what your more junior collaborator really wants to achieve. What are the problems that most engage them? And at what level is that engagement? I mean, to what extent are the deepest passions for the technical aspects or for the consequences of and goals of the research? And what are obstacles that people are dealing with? And that, again, it can be technical, it can be personal issues, it can be, financial challenges, and you have to try and get administration involved to help with setting students, trying to support relatives on a stipend. And, so it just runs the huge gamut. And for me, obviously, you have to read papers yourself and recommend that the student read paper. I mean, you have to do, the obvious things. And I should start with that a good mentor does, which is, learn literature and figure out what are the important papers and review them with the students and try and develop a problem and kind of take for granted that that's the baseline that everybody with any sense would do. But beyond that, it's making student comfortable or the mentee comfortable with the fact that they don't know something, that they don't understand, they have anxiety, it's not moving as fast as they want, they don't know whether the problem is soluble, and just saying, oh, that's great, you're doing it right. Because if you knew exactly what you were going to do, it wouldn't be research. So, don't be deterred by uncertainty. And a certain amount of anxiety in dealing with the unknown is to be expected. I don't know if that helps at all, but again, it's all I got.
Thank you.
That's a great question and a great answer too, and returning to comfort with uncertainty. It seems like another
Yes,
theme.
that's the theme.
Yeah, this evening. Are there any other last questions?
I have a question, Nan.
Please, yes, Nan, please.
Hi, Victor. It's lovely to see you, and it's been such a wonderful interview. Thank you for such good questions, Andrea, and such articulate answers. And I really especially enjoyed your remarks about messaging, since so often I think statisticians don't have as much influence as they could. But when I think back about the COVID messaging around the vaccine, so my understanding, and I could be completely wrong about this, is that the initial promise was that it was going to reduce the spread. And so if you took it, the possibilities were less that you would become infected, and if enough of us took it, that we'd have herd immunity because the virus would just die out. But it seems to me, and maybe again, I'm not convinced of this, but it seems like the message now is that it's going to make the illness less severe. And I'm just wondering if that was predicted at the time that it was first released, and was there messaging around that? It's hard for me to see how it could have been predicted, but maybe it was.
Well, first, Nan, I want to thank you for coming and for the kind words. Nan and I have been interacting now for 45 years, and even before I started my doctoral program. And I know that Nan has high standards, so any praise from you, Nan, is
Yeah.
very much appreciated.
Thank you, Victor.
With regard to the COVID vaccine goals, I was involved in a WHO working group for study designs of COVID vaccines, and WHO ended up doing their own study, but was influential in the designs that were developed by industry. And I also read all of the FDA reports, and it was pretty clear that the studies were designed to and reported as reducing severe disease and death.
Oh, okay.
It wasn't even reducing incidence.
Mhm.
And I don't know of any designs that were attempted at that in the early stage that were even looking at infectiousness. But
Mhm.
clearly, for someone who's highly knowledgeable and with your experience, had the sense that it was a focus on transmission. That shows a failure of messaging, and an important one. There was, and in fact, Ree and I, with others, were working with a group in Seattle, which has the Stat Center for the COVID vaccine studies, and headed by Peter Gilbert, who spent some time with our faculty, Elizabeth Brown. And we had some discussions about trying to do transmission studies, which are quite challenging.
Mhm.
They actually, that group attempted to do one, household studies, which are very difficult to recruit. And Rhea and I found that out when we tried to do, and I should mention that Joanne Manson and Rhea are leading up a study of the effect of vitamin D on disease severity and on acquisition of COVID. And we really we designed this as a household study. We have what I think is a nice paper on a household study. We just couldn't recruit a household study. So in fact, one of the things that Rhea and I and Ravi and a colleague UCSD did was write a paper about how you could use network methods to study transmission without having to recruit households. We just had the much more modest ambition of recruiting the whole campus of UCSD. But I think what you said, Nan, is spot on, that we need to understand vaccine effects on transmission. And we need to understand how those effects change as new variants evolve further and further away from the variant for which the vaccine was designed. And we need ways to more effectively communicate what is known, what could be known, and what the challenges are. So I will leave it at that, except to my thanks again, Nan, for the question and for coming.
Thank
Yeah.
you. Yeah.
Such a great question, and thank you for that. And it's really, it does sound like there was some disconnect between those early studies and the messaging around there. And I have a colleague here, Dr. Tony Tawitai, also a HSPH graduate, who's been working closely with me on some of the long COVID stuff. And one of the things that we're seeing that really wasn't predicted a year and a half ago as we were designing the long COVID study was the reinfection rates that we're seeing now. And so I think also, some of that early messaging and the early studies were not really understanding fully what was to come in terms of the reinfections that we're seeing. So
Yes, it's pretty striking. I'm bowled over by what I'm hearing, because just sort of socially, what I hear people believing is that the vaccine helps protect them from getting infected. And that's a pretty strong belief about the reason why they're getting the vaccine, and also why they're so puzzled when they have the vaccine and all the boosters and they still get infected. I find that amazing because I do believe that's a widespread belief.
Well, Nan, I think that there are so many aspects to that question, and I'm sure many people were well beyond the hour, and
Right.
many people will have to sign off. But I would like to respond to that, because there is a reason to hope that vaccines could reduce the risk of acquisition of COVID, and that would, reduce the risk of transmission. Obviously, if you don't get it, you can't transmit it. But it really is not well studied. I think we could understand that much better. But those beliefs have to do with investigations of correlates of protection, which is also basically mediation analysis. And Peter Gilbert and colleagues wrote a beautiful and very detailed paper, on the topic. And again, it suggests that they might protect, but really, when you have vaccine against the variant, that is targeting what's circulating. And so, Peter's paper, my takeaway is, it might be sort of on the ballpark of flu, which is 40% protective. But I think now the belief with the current variants, at least what I've read, is that there's not that, much effect on acquisition. And partly it's because the vaccine beneficial effects don't get to the nose and the pharynx. They get, or at least not to the nose, where it's the point of entry, but still beneficial with severe disease. And yet you do sometimes read commentary that because people have so much more antibodies, either from prior infections or from boosters, that there should be lower risk. But that's me. I hope it's true. It's aspirational, but you can't make anything like the statement you could make that if you got the vaccine in February of 2021, that you were at much less risk for as long as that wild type variant was circulating. That you nailed down.
Right.
Well, thank you. And being brought back to memories of sitting in working groups with the two of you, Victor and Nan, and it's wonderful to hear the back and forth and your conversation. It is past the hour, so I do want to just take one more chance to thank Victor for all that you do, for joining us this evening, and also for being such an inspiration to so many of us. So thank you for that, and hope to see you all soon.
May I just express my thanks to
Absolutely.
everyone for coming, in particular. Thanks to Andrea, to Kristen, and Amanda for making this happen. It's really been a wonderful experience. Thank you.
Thank you.
Thank you all.
Thank you.